Hello everyone, today it's time to learn the theory of probability. Whenever we say the word probability, it literally means the chance. So the theory of probability actually deals with the laws of governing the chances of occurrence of the phenomena which are actually unpredictable in nature. So before we go to the classical definition of probability, we will have to be familiar with some terms. So we should know some definition of few terms. So let's have a look which we are going to learn in this video. So let's have a look what we are going to learn in this video. At first experiment, then random experiment, number 3 is sample space, and number 4 is events. So at first experiment, what do you mean by the word experiment? It is an act which can be repeated under identical or uniform conditions. So experiment means an act which can be repeated under identical or uniform condition. But there is a difference between experiment and random experiment. Random experiment is an experiment, but in that case, in that type of experiment, we have the knowledge of all possible outcomes in advance, but we cannot predict what outcome is going to happen. Like tossing of a coin, throwing of a die, these are the example of random experiment. So when we are tossing a coin, we have the knowledge of all possible outcomes, like either head or tail will come, but we cannot predict what outcome is going to happen. Same is happening for the experiment throwing a die or drawing cards from a pack. So these are the example of random experiment. Now I am coming to the definition of sample space. For any random experiment, the sample space is the collection of all possible outcomes. So the set of all possible outcomes is known to be sample space for any random experiment. Suppose we are tossing a coin. So if the head is denoted by capital H and tail is denoted by capital T, and this will be the collection of all possible outcomes in case of tossing of a coin. So if this collection is denoted by capital S, then S is said to be the sample space in that case. So S is the sample space of tossing of a coin. Now I am coming to the definition of an event. If S be a sample space, then any subset of this set is said to be an event. Like if we toss a coin, then sample space S will be H and T, that is either head or tail will come, and if we take any subset of this set, then this set will be said to be an event. Like if we take H, this is a singleton set and this is a subset of this set, so this set is said to be an event. So any subset of the sample space is said to be an event. By the way, this is Dr. Ruchira Choudhury and you are watching me on Infinity Math. This is a newly open channel and you will find videos related to higher mathematics here. If you want to discuss any chapter of mathematics, please let me know through your comments, and you can also join in my WhatsApp and Telegram channel whose links are provided in the description box. Now it's time to learn classical definition of probability. The probability of an event A is denoted by PA and is defined by PA is equal to NA, that is the number of element of the event set A, divided by the number of elements of the sample space S. Now I am giving you an example to clear this definition. If I toss a coin and if I ask you what is the probability of getting head, we all know the result is half. Now I will explain by the classical definition of probability, why the result is half. Now if I toss a coin, the sample space S will be equal to H comma T, that is either head or tail will come. Now in that case NS is equal to 2, that is the number of elements in the sample space is equal to 2. Now the event A is equal to H, because I am asking you what is the probability of getting head. So the event A is H, that is the singleton set. Now we have to find out PA. PA is equal to NA divided by NS, that is the number of elements of the event space A divided by the number of elements of the sample space S. Now number of elements in the event space A is equal to 1 and divided by number of element of the sample space S is equal to 2, that is 2. This is the result by the classical definition of probability. So I am giving you another example. Find the probability of getting at least one head in 2 throws of a coin. So I am throwing the coin 2 times. So what will be the probability of getting at least one head? Now in that case, what will be the sample space S? The sample space S will be equal to HH, HT, TH and TT. Suppose this is first throw and this is second throw. So I can get a head in both throw of the coin. Now I can get head in first throw and tail in second throw, and I can get tail in first throw and head in second throw, and I can get tail in both throw of the coin. So this is the sample space. Now I have to find what is the probability of getting at least one head. Now suppose A be the event of getting at least one head. At least one head. Now what will be A? A will be equal to HH, HT and TH. That is, there is head in both of, there is at least one head in every terms. So HA, this is H, H and H. There is at least one head in every term. So this will be equal to A. Now I have to find what will be the probability of A. That is probability of getting at least one head. Now from the classical definition, probability of A equals to NA divided by NS, that is the number of elements in the event A divided by the number of elements in the sample space S. So there are 3 number of elements in the event space A. So 3 divided by, there are 4 number of elements in the sample space S. So 3 divided by 4. This is the probability of getting at least one head. Okay, this is all about some definition of some few terms related to theory of probability. This is just the introduction for the beginners, and in my next class I will discuss more about probability and will solve problems related to it.